Good morning. Sorry for the missed bell. The bells are back on. At this time, seniors with the last name A to K, if you need an ID picture taken or replacement ID, you should head to the LMC at this time. Again, seniors, last name A to K, and you need an ID picture. In other words, you don't have one. You should head to the LMC at this time.
So in the progress check, number 9.
Progress check number 9. I'm listening, dear.
It just is like it's like shows like the like metal, like kind of like lattice thing.
Mm-hmm.
And it's like it kind of shows. It says that it like I looked at the answer key and it shows malleability because it like moves relative to another. But couldn't it also be electron conductivity because it also shows like the electron C and like shows that like how the ions are immersed in the electrons.
But there's no electrical current present, so that you can't prove that it's conductive of electricity if they don't have a current shown.
Even though it has the electron C.
Yeah, but it's not conductive. You can intune that it, you can guess, but you can't confirm that based on this drawing.
Okay.
So there's no confirmation of that based on the drawing. Does that make sense?
Yeah.
But it does show malleability because it shows how they can be like moved. Again, I mean, for the same reason, the C is out because it says heat conductivity. But you can't tell that because there's no heat present. They don't have anything shown like temperature differentiation or anything like that.
Okay.
Progress check question. Yes.
Can you do FRQ, C, and D?
FRQ, C, and D. Let me see if I have those files on here. It'd probably be easier to pull it up and look at the files. Downloads, Unit 2. Yes, this is the document that we desire.
Yeah.
Okay, which number was it again? I'm sorry, honey. C and D. Was there just one number on here?
Yeah.
Okay. All right, so we have the graph here. And indicate the distance that corresponds to the N2 molecule by placing an X on the horizon. Let me go back up and kind of 2 versus their new between. Okay, so indicate that indicate that corresponds to their bond length. So the way that I figured that X went here is, and I don't know if this will okay. So what I did was I looked, it just needs stuff to work.
Happy Monday, Lucky.
Yeah, happy Monday. So what I did was I found the bottom of this and I went straight up because this is where that bond is going to be found. And if we're looking at distance, that's bond length, same, just fancy term for it, okay? That's where it's going to be on that x-axis. Does that make sense? How I kind of rationalize that? And then what was D? On the graph, show the sketch that corresponds to 2 oxygens. All right. So nitrogen, when we look at that structure, and a lot of this comes down to structure, you guys, you have to like either be able to visualize these things in your head and get this in your head, or you have to draw them out. Okay. And I'm guessing with the experience that you've had, you need to draw them out. It's the only way that you're going to be able to figure this out at this point. Okay. Like I have this guy memorized because I've done this for so many years. But until you get to that point where you can go, okay, oxygen looks like this, You know, I don't have to count electrons on that guy anymore. I don't have to try to figure out if it's a double bond. I've got that one memorized, but you guys might not. This is a double bond. Okay? It's not going to be as close as a triple bond, especially when these are in the same period. Now you take this versus, you know, we get all the way down to like PO or something, okay, which is a metal and I know in it. But if you did this guy versus the oxygen here, you know, this guy probably is a bigger because he's further down on the periodic table. These are both in the same period. So you're taking that kind of, oh, this doesn't erase the right way. You're taking that kind of element out of it, okay? So these are in the same periods, okay? This guy, because he's a triple bond, is going to be tighter in than the oxygen. So the oxygen's going to lie on this side of the nitrogen's drawing, okay? And he's not going to be as high up because he's only a double bond, not a triple bond. So this is going to have more potential energy, you know, down here. It's going to go down lower versus this guy.
So then for something like phosphorus, would it just end up going lower down?
If we were comparing phosphorus to nitrogen,
Yeah.
No. Phosphorus would be something like this. Because remember, it's going to be the atoms are going to be bigger in phosphorus because they're one level down. The distance is going to be longer just because it's gone one level down. Okay. Did that answer somebody? Grace. Okay. Sorry. All right. What else do you guys want to talk about on progress check?
Number B.
B as in boy?
Yeah.
Okay. Okay, so based on loose dot diagram is the N2. Okay, so that one, if you're just trying to figure out polarity, nitrogen has lone pairs of electrons. You don't even have to think about it anymore. But, wait a minute. Hold on.
That's when I was confused.
Okay, hold on. Wait. Yeah, because everything is equal. And this only really happens in these diatomics for the most part. Okay. And there isn't really a central atom here. Okay. So when we talk central atom, we have to look at that, you know, that it's a central atom. There's no central atom here. Okay. So the lone pair of electron idea doesn't come into play because we don't have a central atom. Okay. When you have a central atom, then that changes everything. So if you have, for example, water here, well, this looks symmetrical. Like if you were to draw a line down, this half would look the same as this. This is a central atom. So this is going to have lone pairs of electrons. This is going to be polar all day. Okay. This guy doesn't have a central atom. Everything is going to be in balance here. Everything's going to be, because remember, this is a three-dimensional object. Okay. So everything is going to be balanced out there. So it's around the central atom. Trying to think of a couple examples. Why is it that you can never think of the examples that you want to think of? The number 11 here is number 12 here. Let me just go down to that. Or up. I guess it would be probably up. No, this is home. Is this homework? No, I was going the right direction. I'm sorry. Here, this is a So here, there's no electrons around this central atom here, no lone pairs. And these are both oxygens, so everything's going to be shared equally. So this is going to be a non-polar molecule. Even though these are polar bonds, okay, because if you looked at the electronegativity, they'd be polar bonds. It still ends up, the dipoles, these things are called dipoles when the electronegativity differences exist. Those dipoles are going to cancel one another out. Now you come over here and you look at this. This one is likely going to be a polar molecule, okay? Because you've got dipoles around here and only one dipole around here. So it's likely not going to cancel out here.
Staple all the letters up there.
Well, how are you going to get them to stick?
I didn't know if they were sticky.
No, they're not.
They're
Because
not.
I want to reuse them from year to year. So only use one staple in each one if you can manage to get it to lay there.
Okay.
Because I want to try to reuse them.
Gotcha.
Gotta love it, Libby.
We did 2 and 3.
Did that answer
Yeah.
members' question? 2 and 3. Okay, so that must be multiple choice, right? Which of the following claims about a binary compound in which the bonding is ionic is most likely to be scientifically valid? So, ionic. When you hear ionic, so binary, first of all, you should know is 2 elements, right? Bi means 2.
When it says binary, does it mean like the same element or like just any 2
No,
elements?
and it's typically going to be 2 different ones because technically, if you have a diatomic molecule, that's technically not a compound.
Okay, I get that then.
But when you see ionic here, that's automatically metal and nonmetal, so it can't be the same compound. So both elements in the compound are not, you can't do that with ionic. The atomic masses of the elements are relatively small. You maybe, but you don't know. There's equal sharing of electrons, not when you have an ionic compound. They don't share at all. Okay, so that only leaves D. And then number 3, again, binary, 2 elements, same electronegativity. That's probably going to be nonpolar.
Okay, yeah, I get that. I was just confused about like the binary compound.
Well, anytime you see the prefix bi,
Yeah, I get
that should be a 2. Like a bicycle has 2 tires. What else? So you guys are ready to ace the test? I give it to you right now. You're good? Then what do you have questions on? Okay, so memorization of the structures. If I had to concentrate and could only learn just a handful of them, and I only had just a little bit of time to do that, how would I do that? First of all, if you think about 2 elements coming together like this, okay? Imagine that. Imagine that that's created, okay? And you're just visualizing the 2 elements coming together. They would be in a straight line, right?
Uh-huh.
And the angle between these 2 would be what?
180.
180. So that's 180. Just from geometry alone, you can kind of get that. This is in a single line.
Okay, students,
This is
we are
linear.
now taking seniors with the last names beginning with A through R in the LMC to get an ID. Thank you.
If I have this guy, I have, and the problem with these lone pairs is that sometimes it's hard to visualize those, okay? So kind of think of them as something that's coming out like this, okay? So you're looking at 2 different lobes that are coming out. These are substantially larger than these, okay? So if you imagine that, but this is now in a 3D kind of world. Okay, do you need me to get balloons?
No.
I'll get the balloons. Okay. So if we've got this in the 3D dimension here, it's going to push, these guys are going to push down on these, or they're going to bend them. Okay. And your bond angle is 104.5. That you just have to commit. Okay. Now, imagine this, but this time we've got nitrogen here and we've got hydrogens coming off of here. Now we've got one big domain up here and these guys are down here. Okay? So this is going to form down here. If you looked at it, it would look like a pyramid, wouldn't it? Because you would have these three things coming down off of here.
No, Instagram for Chase.
Oh.
He sent it to himself, didn't he?
Oh.
Thank you.
Yep.
Bye.
Bye.
Have a good one.
All right, so this is going to be trigonal pyramidal. Okay, trig means three. Okay, so you've got three elements. So does that make sense?
Yeah.
Trigonal, and then it forms this pyramid down here, in there. So that helps you visualize that. Bond angle here is 107.5. All right, now we take this and we have this guy coming off of here. Okay. How many things are coming off of this carbon?
4.
4. What is the prefix for 4 in naming structures and all of those things? Tetra. So that's where they get tetrahedral. And the bond angle is 109.5. Okay. Now, if I had to memorize and I could only get 4 of these in my noggin, these would be the ones that I would get. Okay. You may lose points because you don't get the other ones, but if I had to commit, and I haven't looked at the test since last year. I do not remember which one's on there, so do not yell at me if that, if I didn't cover it in this little brief thing here. So if you get some weird thing going on. Yes, Maddie.
Number 15. Multiple choice.
Nope. Crap. All right. 15, multiple choice. Okay, that was the one that I just had drawn up here. So based on this, which one is the angle closest to? Okay, so this angle would be what actually? What have I taught you that this angle would be? 107.5. So what's the they're just giving you options here. Which one's the closest there? Right. Okay. And they will give you like wiggle room a little bit in your FRQ. Like they'll give you a range. So they will say anywhere between 103 to 10 something.
Give us a range.
I give you whatever range they gave on that AP exam. So my answer key I pulled off, and I do the same answer key with the same thresholds that they gave on the AP exam that was originally given. So was this just because it wasn't 107, Maddie?
Yeah.
Okay. What else?
I just saw that it was 0.5 and I was like, it's that one.
Gabe?
one on 2.7 each.
Whistle back there.
Okay, what number was it again?
180.
Is that boron trichloride? Remember boron has a reduced octet. Boron is happy with how many electrons? 6.
Oh, yeah.
Was it chloride?
Yeah.
Reduced octet. Boron.
Why is that an sp2 instead of sp3?
Okay, so when you're looking at that, you're trying to figure out how many p orbitals are going to hybridize. Okay, and you would have for your boron, you would have 1, 2, 3 sp orbitals coming off of there to connect with your chlorine. Okay, and that means that you would have taken an S and 2 P's to make that.
So does the finger trick not work?
Not on this one.
That's bad news.
Well, wait until you get to college where they hybridize the d orbital.
Well, I'm taking this class, so I don't have to take it in college.
That works if you're like a business major or something. Yeah. If you're going to be a medical major, engineer, stuff like that, a lot of times it won't. Yeah. You're going to have to keep climbing. You're going to have to go above Lippy's level.
I like it. I'll switch my dream profession.
And like I said, the shapes, thank you, gentlemen. Did those have names on them at all?
Oh, these are all done.
Okay, thank you. Just throw them in the trash then.
Oh, wait.
We don't recycle
Like
here.
the actual like orbital shape.
As opposed to like the name.
Do you need to ever be able to do this? No. No, you never have to do this, ever. Okay? You're not going to have to do that. It's just sometimes when I'm trying to explain it to you guys, I think I hope that it helps you visualize a little more. An S versus a P.
How did you get to that from the actual bootstraps?
These are called sigma bonds. The single bonds are sigma bonds. Okay. Anytime you have a sigma bond, it's going to be in a hybrid orbital.
So it like joins together the P and the S.
Yep. So for this guy, you would have started with these 3 things: an S, a P, and a P, and they would have hybridized to give you an SP, SP, SP. So you started with 3 things. You end with 3 things. How many P's did you have to throw in there? 2.
Oh yeah.
Good. What else? Sounds of silence. All right, good.